Greetings, welcome back to Speech Understanding. Let's go ahead and open a Jupyter notebook and I think this week's lecture may be rather fast. So far, as you know, we've been working on automatic speech recognition, and this week what I want to introduce you to is the speech recognition package in Python. So let's try it. Let's open the Jupyter notebook. All right, let me go ahead and open KCGI, Intro Speech Understanding, Lecture 11. So in the last 2 weeks, you've learned how the basics of automatic speech recognition. 2 weeks ago, you learned that a speech recognizer is a model which has been trained using paired audio and text transcripts. And then it's tested by taking that audio and comparing it to every possible transcription to see which transcription is best. Last week, we re-implemented that same idea using a neural network, using the PyTorch neural networks package in order to see the basic idea of how speech recognizers work in the modern world. This week, what I want to do is to introduce the speech recognition module. This is a module in Python that you can install using pip install speech recognition that does this wonderful thing. It makes possible all of these different automatic speech recognizers. The Carnegie Mellon University Sphinx speech recognizer works offline. This is a software that's downloaded with the speech recognizer. All of the others here are, you need to be connected to the internet to use them. So you can use the Google Cloud Speech API, the Wit.ai, the Microsoft Azure Speech, Houndify, IBM, TensorFlow, OpenAI Whisper, or Grok's Whisper API. All of these are speech recognizers that are made available made available through an application programming interface so that you can log in and use them on the internet. And basically, the Python package is just an access to the web page where you can get access to that speech recognition module online. So this speech recognition package is just a simple way of opening it. So it does something like this. You recognize speech recognition speech input either from the microphone or from an audio file. I'm going to use an audio file in this class simply because Jupyter notebooks don't allow me to record from the microphone. So I'm going to do speech recognition from an audio file using the speech recognition module. So to use the speech recognition module, the first thing you have to do is just to install it. We just install pip install speech recognition, and then it will install it if it hasn't already been installed. Using it is actually quite straightforward. Let me import librosa to read a waveform, and then let me import IPython display in order to show that waveform. And this will be, I think, the speech waveform that we've already read. This is a speech waveform. これは音声波形です。So this is just a simple speech waveform in English and Japanese. And what we want to do is to take that waveform and transcribe it as audio. All right, so to do that, we import the speech recognition module. And then the steps in order to use this module are, first of all, we have to create a recognizer. This is just creating a recognizer object, right? And then we have to create an audio file. We read in that audio file as a source. And that audio file has to be in a .wav format. So if it's in any format other than .wav, then we have to convert it, perhaps using librosa or using some other method. And then once we've got that audio file opened as the source, then we read in from the source. So we take the speech recognizer, R, and in that speech recognizer, we record from the source. So basically, we take the audio from that input source and read it into the speech recognizer. And then we recognize it using one of the available speech recognizers. I'm going to use the Google Cloud API. So I'll type r.recognize Google. And what that will do is it'll take this audio object that's been read in from the audio file, and it will convert it into text. And it will list out the result. So in this case, it says the person in this audio file said, this is a speech waveform, 11 seconds. All right, so kore wa onsei hake desu got completely left out. It recognized the English part, but it left out the Japanese part. Obviously, the problem is that this Google Speech Recognizer is expecting English, and it had no idea what to do with the Japanese. And so it just left the Japanese as noise, as random background noise. All right, so in order to recognize universally across languages, this may not be true for very much longer. It may be that most speech recognizers will soon automatically switch between languages. But at least for now, we need to tell it which part is English and which part is Japanese. So for example, we can plot the entire waveform and just look to see, is there an obvious pause in the middle? There's an obvious pause in the middle. And so clearly the first half must be the English half, and the last half must be the Japanese half. So we want to recognize the first half using the English speech recognizer, and we want to recognize the last half using the Japanese speech recognizer. So we can read in this audio file as the source, and then we can just recognize the first 3 seconds as English. You can see that I've plotted this with a time in seconds, and the time in seconds, 3 seconds is in the middle of this pause. And so if we just recognize the first 3 seconds, that should give us this is a speech waveform. So there it gives this is a speech waveform, and this extra dark garbage 11 seconds, where it thought that when I said kore wa onsei hake desu, it thought I was saying 11 seconds. Now it's left that out. Now it simply says this is a speech waveform. That's almost all that I have to cover today. The only other thing I want to talk about is how do we deal with the second half? How do we deal with that Japanese language half? Right? In order to handle languages other than English, most of these speech recognizers that are listed in the examples here, most of these speech recognizers will handle both languages equally well. We just need to tell them what language to expect. So in this case, I'm going to recognize that audio. Here's the audio object that I've read in from the audio waveform file. And I'm going to recognize it using the speech recognizer, but I'll tell it that the language is Japanese. And then it will tell me what the file says in Japanese. First of all, let me try recognizing the entire audio file as if it were Japanese. And it actually recognized that the first half is English, but it didn't do very well for the first half. Right? The second half it got perfectly. Kore wa onsei hake desu. So for the second half, it correctly transcribed the Japanese perfectly. The first half, though, was in English, and it tried to recognize that English as if it was code switching inside a Japanese sentence. It thought that I was speaking Japanese, and in the middle of that Japanese sentence, I said some English words, and it tried to recognize those words as if they were part of a Japanese sentence. And that's incorrect. And so it got, up here, we managed to get exactly the correct transcription. This is a speech waveform. Down here, we got this is speak from, right? It doesn't quite recognize the English as English because it's trying to recognize it using the Japanese language speech recognizer. It does pretty well, but not perfectly. And so in order to make it perfect, what we need to do is just divide that sentence into two. We'll recognize the first 3 seconds using the English language speech recognizer. And then once we've recognized the first 3 seconds, then if we record from the rest of the source, so here I will record from the source just the first 3 seconds of that file and recognize it using English. And then I'll record all of the rest of that file and recognize it as Japanese. So notice that because I've already opened up the audio file, once I record the first 3 seconds, then once I start recording again, the second part reads from the place where I left off. So if I stopped at 3 seconds, then this starts after the end of those 3 seconds. So if I run this code, it will recognize the first 3 sentences in English. This is a speech waveform. And the last 3 seconds in Japanese. Kore wa onsei hake desu. And in that way, it gets perfect recognition of both the first 3 seconds and the last 3 seconds of that waveform because I've warned it in advance which language is which. As I say, it might be the case that a year from now, we won't need to do this. It might be the case that a year from now, you'll just recognize and it will automatically switch the language. But at least for right now, it's still the case that it's beneficial to tell it in advance which language is which. I'm not going to use microphone input for the homework, but if you want to try to create your own speech recognition application, if you want to create a dialogue agent that you can talk to in real time, you might want to recognize the input, use it directly from the microphone. And you can do that. You just can't do that actually in a Jupyter notebook. In the Jupyter notebook on an Apple, at least, it will hang because it will not be able to recognize the input. But the way that we do that is we first create the recognizer the same way. And then instead of using the audio file as the source, we use the microphone as the source. We say with speech recognition.microphone as the source. We adjust for background noise. Ambient noise means background noise. We adjust for background noise, and then we try listening to that source. And if we get any audio, then we try to recognize it. In this case, I'm going to try to recognize it as English. And then it will say, if it gets an unknown value error, that means that it didn't know what the transcription was. It got an audio that it couldn't recognize, and so you want to try again. And I'm going to use the continue here to mean go back to the beginning of the while loop and try over again. If you get a request error, that means that it couldn't contact the internet. So we'll print, sorry, I could not reach the internet. I will try again. And then we'll continue. We'll go back and do the loop over again. If you get a wait timeout error, then that means that the audio just, it listened to the audio, it listened to the source, and it didn't hear anything. It was just silence. And so in that case, rather than saying anything, you want to just continue. And I think this won't work. Let me try it and find out. This is a test. Can you hear me? Oh, it works now. Wonderful. So actually, it used to be the case that Jupyter notebooks would not listen to the input, but now apparently Jupyter notebooks have been changed, and so now apparently it will listen to the input. So we read in from the microphone, we adjust for background noise, we try to listen to the source, and then we try to recognize it using English language. Let me try it again, and what I'll do is I will just wait, and it will wait timeout and continue. And then it will print Python is listening again, and it'll keep listening until I say something. Let's try that. Let's try this. Is this okay? Yep. So it said Python is listening, Python is listening, Python is listening, and then it said, let's try this. Is this okay? Let me try now saying some gibberish and see if it can print out, I did not understand that. I'm not sure if this will work, or if it will just print out the gibberish. Maybe I'll make a raspberry noise or something. Let's see what happens. There we go. It said, I did not understand that. I will try again. All right. So in the first case, I made this noise, and so it said, I did not understand that. I will try again. And that's because it got this unknown value error where it heard a noise, but it didn't know what the noise was. The other error that can happen is a request error, which happens if it can't contact the internet. But we haven't been able to see that because if I turn off my internet, then you won't be able to hear me anymore. All right, that's all I wanted to talk about today. I mean, really, I wanted to introduce you to this extremely useful package, the speech recognition package, which is an open source application programmer interface that just makes it possible for you to write Python code that includes any one of these speech recognizers. OpenAI or TensorFlow or IBM or Google or Microsoft all become available to you in this package. The homework is just going to be implementing pretty much exactly the same thing that we just did in the lecture. So let's take a look at the homework. We just want to transcribe a WAV file where we're given the file name and the language. So let's get rid of the runtime error. And I want to do the same things that I did here. Let's see. I want to open the audio file as a source. So let me copy that here with speech recognition.audio file, and I want the file name here. as a source. And then I want to read in the audio from that source, but not with a fixed duration. I just want to read in from that source all of the audio. And then I want to generate the text. And let's use the Google Recognizer. Let's assume that we're connected to the internet so we can do that. And then I just want to return the text. Let's make sure, is there anything else I need? I need to generate the text and then I need to return it to the user. I think that's the entire homework, just 4 lines. Open up the source. Nope, I need to create the recognizer first, don't I? How did I do that? Um, don't I need to create the recognizer here? R equals speech recognition dot recognizer. So let's go over here and create a speech recognition recognizer. R is equal to speech recognition recognizer. And then with speech recognition audio file as the source, then that R can record from the source and I can use text. So it's 5 lines. I need to create the speech recognizer, open the audio file, read audio from the audio file, and then convert it to text, and then finally return the text. I think that's all I need. Let's test it in the Jupyter Notebook to find out if that's all we need. So first of all, we'll print the doc string. There's the doc string, and now let's try running it. Speech recognition is not defined. Oh, because I imported speech recognition as SR here. Well then, let's change this to SR. So we have sr.recognizer, sr.audio file. I think that's all of the instances of SR, of speech recognition. Now let's try that. And it read it in as, this is a speech waveform, 11 seconds. Let's see, I think that the grading will not work here because I think the grading has the transcript from last time. Oh no, it does work, 100%. All right, excellent. So now all we have to do is check it into GitHub. We'll commit it and then push to origin. And then let's go and check to make sure that it showed up on our GitHub page. Let me switch to my student account and check to make sure that homework 11 showed up. There it is with all of the updates. So we'll copy this and then we'll go and check it in on the King LMS page. Go to homework 11 and where it says enter the URL of your copy of homework 11, just copy the URL there and then I will grade those and give you the score. That's all for this week. So let's go ahead and take attendance and then we're done for the week. And then next week we will start on speech synthesis. We'll start with the theory of speech synthesis, and then the following week we'll do the actual speech synthesizer, and then the week after that we will introduce the speech synthesis package. All right, please go ahead and register your attendance using this code. Let me turn off the recorder too.